I've been mulling over in my head for the last couple days about making this video. So first off, let me preface this video by saying I am not the end-all, be-all on Mach 3 or hardware or anything like that. I've been doing this for about 20 years. I make a living at it, but I haven't seen or tried everything. The side note to that is I've been doing this for 20 years with these desktop CNC machines and Mach 3 and the electronics and the controller, stepper drives. So I've played with a lot. I haven't played with all. And I also know that there are a lot of people out there that are more knowledgeable on this stuff than I am. All I can do is base this video off of my experiences. So I've dug through my hoard of stuff and I pulled out all of this garbage. So I belong to a Mach 3, Mach 4 group on Facebook where I try to help people, and I'm seeing a surge of these cheap Chinese CNC routers, like the 3040s. I think there's a 3018, there's a 6040, the 6090. Now the chassis on those machines, meaning the machine's frame, they're proven, they're solid. It's everything else that goes with it that is lackluster. Yeah, I'm going to use that word. So I own a 6040 Chinese CNC router, which I got just as a bare frame, and I put my own electronics and stepper motors on. And I was helping a friend out, and he had a 3040 that he just gave me. He could never get it to run, couldn't get it to work, wouldn't do what he wanted it to. I cut a bunch of carbon fiber quadcopter parts for him. He just gave it to me. And he gave me the controller, everything with it. The controller is this guy right here. As you can see, that's not hooked up to the machine. It was. I tested it and played with it. And the problem is, I'm really trying. I don't want to make anybody mad for going out spending a lot of money, but I also want to give my perspective as what I have found and just try not to piss anybody off. They sell these machines anywhere from, I've seen them as low as $800 on up, and they have to make a profit on them. There's a lot of work in the frame itself, whether it's lead screws, ball screws, or what have you, but they have to make it at a price point so they make money on these. And this is the big part where they cheap out. So if we look down here, this is the 3-axis control board, so this 3 stepper drives. And the machine that he gave me did not have a VFD or a 3-phase motor on it. Just had a AC motor, where the brushed motor with the little collet on the end shaft. They're not good, but they're not terribly bad. So that's what this is. And here's the power supply for it. Now the problem is, and this is a off-the-cuff video, and I'm going to try and explain things as simply as possible. This is more of a video for somebody who just purchased one of these machines, trying to get into this, is having problems. So the problem with this is I ran some tests, and it rounds corners, it loses steps sporadically. I'm sorry to say it like this, but this is junk. So back 15, 20 years when I had a Max NC machine, I was running something like this, which is a Xylotech 3-axis control, comparable to that, but this is probably 10 years older than that because this has actually got a USB and a printer port on it. This made my machine run, but it was garbage. It was junk. As you can see, this is theoretically supposed to be, and this had a 24 volt power supply that powered this. So if you have a 24 or a 36 volt power supply in your electronics controller, you're neutering the motors. Motors, I think most NEMA 23 stepper motors are designed for about 50 watts. That's why solid manufacturers are putting 48 volt, not 50 watts, I'm sorry, volts, are putting 48 volt power supplies with their stepper drives, because you're getting the performance out of the motor it was designed to do. Once you put a 24 volt power supply on it, you've literally cut its performance in half just right off the bat. So this is 24 volts. We look down there, we can see that's 24 volts. So I played with this. I ran some tests. It's junk. It's garbage. As you can see, I cut the wires off. So this actually never made it to the trash can, but that's where it's going. I'm going to steal the aluminum heatsink off of it. And I'm keeping this, which is nothing more than the DC motor control. So I'm keeping this, so if mine ever dies, I ordered a new spindle and DC control. So I'm just kind of hanging on to for that reason. Now, this guy, let me move this. So this thing was back from 2000 to 2004, and it's got its 4 stepper drives down here. It's got a relay board. It's even got a 48 volt power supply. This was not bad. It was slow, but it was not bad. It actually worked. And it was pretty stable. And I think all of these down here actually run a printer port input device, or input, but we'll get to that here in a second. So when I bought the machine that this came with, I tested it, and it was slow. That was my only complaint, is I couldn't get the rapid feed rates and the high acceleration that I'm accustomed to out of this. So this got put off to the side. I'm going to rip this out of it, might rip this out of it, and probably rip this out of it. But this is junk. This is garbage. It's underwhelming performance. So let's get this off the table. So this is a pretty unique controller. This came with a tag that had stepper drives, but it also had encoders. If you know what an encoder is the software tells the motor to move a certain distance, and the encoder on the back keeps track, and if for whatever reason it doesn't move that distance, it will cause the machine to stop. Just like a servo motor. If you know what a servo motor does, it's basically the same thing except with a stepper motor. Step in direction. But this is from, I'm thinking 2004-ish. Like I said, it's a tag machine. The guy sent me the machine with the controller. I switched it over to ball screws, put a good solid controller on it with new motors, and it's just been sitting on a shelf. I kind of hoard things just because. All right, this here, 3-axis stepper drive, is quite literally supposed to replace or compensate for something like this. So we have a C76 board here, and we have 4 independent stepper drives. So if you took one of these away, each of these stepper drives, which is kind of something along this line, they want that to replace it with all the inputs and outputs. So that's where they're making their money, is off of this and the wiring and the motors on the little Chinese machines. So we know this is garbage. We're going to put this over there. So a really good solution if you're wanting to upgrade your machine is one of these. So this is in a box, but if you ordered one of these, the Gecko G540, it's just this piece and it's about this thick. So we have our computer input here, and we have our stepper drive out here. These are amazing. This one actually runs my 3040 machine, and I have another one running my 6040. Yeah, 6040 machine. These are amazing. They're in the ballpark of $350 US, but that's without the power supply. So you need a 48 volt power supply. So all that's in this box is the Gecko G540, and on the bottom's a 48 volt power supply. and my motors plug in here. Now these require a little bit of knowledge, soldering skill, because you have these 4 holes here are for the steppers out, and then this one and this one is for a resistor to tell the board here how much amperage to put out to the stepper drive. I'm not trying to get in difficult here or deep here, but these are amazing. They perform very, very well. I love them to death, but I deal with a lot of higher end hardware, so I run these on 2 of my machines because I have them. I have controllers here and there. I've got a couple up there that I can put on those machines, but these are bulletproof. I love these to death. Now these also have outputs and inputs to where you can hook switches, limit switches, home switches, tool probe, and control various other outputs on these. But on this one, as we can see, there's no other plugs. This is not hooked to anything. So the way I use it for my home switches, my tool probe, and my spindle is I take something along the lines of this, which is nothing more than a breakout board with a couple relays and spindle control on the board, and I've got a USB smooth stepper down there, which the PC comes in here. It hooks to the computer. This specific one hooks to the computer versus with a USB port instead of the printer port. So I can use this on Windows 7, Windows 10, Windows 8, 64-bit that does not support a printer port out. Now, the conventional and the way Mach 3 normally works is you've got 25 pins on a printer port. And those specific pins are either inputs or outputs. Now, the problem with the Chinese stuff that's coming out that is using USB and Ethernet connection to connect to the computers, because computers no longer have printer ports, is they've taken the conventional way Mach 3 uses the pin numbers and have really just turned it on its head. And what I mean by that is, that's not going to stay. Oh, and while I'm at it, I was working with a guy. He reached out for some help, and that was his 4-axis stepper drive. USB in from the computer. Each one of these little things is a stepper drive. I think it's 12 to 36 volts out. And he was running a very large router. I think it was a 4x8 or something along that lines. And he kept blowing these modules because his stepper motors were way too big for this. I just keep this as this is supposed to replace that. You see the difference? And that's a very basic controller that I've had since I want to say 2007. We'll get to that maybe if need be. Anyway, junk, garbage. So the way Mach 3 is used to work, or was designed to work, is if we have a look here, we have X-axis, Y-axis, Z-axis, A-axis. And we break out the pin numbers for the printer port. Pin 2 and 3 are step and direction on port 1. You have multiple ports you can have. 4 and 5 for step and direction, port 1. 6 and 7, port 1. 8 and 9, port 1. So the way this thing is laid out, and the way this is, which I know we can't really see, and I'm sorry this video is all over the place. I have a bunch of stuff floating around in my head. And this is a mess. I know it is because I bastardized this. I put it together hastily. But down there, there's a red and a black wire. So this one's 2 and this one's 3. If we follow them up, they go to the step and direction of each of these stepper drives. So if we go 2 and we follow it, it goes to this cable or this port here, which goes out to the next controller. So that would be step and direction for X, step in direction for Y, step in direction for Z, step in direction for A. And we also can pass through, actually these are not pass through, so I think that's all that really goes. And the E-stop, which is on pin 10, normally it's always on pin 10, or that used to be the default, the convention for it. So all of these wires up here just go to this, to the corresponding pin, and then a cable can go out from here into something like this if it didn't have the relays or a simple G540 here. So I could put my spindle and my home switches and have a coolant relay out, power out, going to something that requires a G or an M code to turn on, off and on. And it hooks to the PC with a USB instead of a printer port. And this here is a remote pendant. We won't even talk about that. No need. So this thing here is wired the same way. This board down here, all of these screw terminals are labeled what pin they are. And if we look at Mach 3, so if we go to input signals, we can read down here, pins 10 through 13 and 15 are inputs. Those are the only 5 pin numbers that can be on the screen. Output signals, 2 through 9, 1, 14, 16, and 17. So they've designated which can be inputs and which can be outputs. So the problem, one of the big problems is, this here's a VFD that runs a 3-phase spindle motor, or a high frequency spindle motor. A lot of the Chinese distributors are taking this and trying to put it in, or are putting it in with these stepper drives. These create a lot of RF noise, so it's best to have these as far away from all this sensitive stuff that's throwing pulses in and out. Keep it away from that. So if we look here, I've got a VFD there, my spindle controller's down there, machine's up there. My other 2 machines are set up the same way. The VFD is as far away as I want to possibly make it. And this here is nothing more than a breakout board with a smooth stepper in it, which is, the smooth stepper is a motion controller, the interface between the standard electronics and the computer. So everything on this board has got a pin number. So if we read here, this relay is pins 1 and 6, so that's 1 and 6. We can go through and decipher what all the pin numbers are for all this. This here is a UC100 motion controller. If I was using this to power my machine and I had to get a new computer because my old Windows XP or whatever died and all I can get was a Windows 10, you could take this with a gender changer, plug it in right there, and it follows all the same old conventions. So that's a simple way to go from printer port to USB connection to the computer. This here is a UC300 on a C76 breakout board, and the same conventions apply. Each one of these features and functions has a port and a pin number attached to it. You can get on their documentation and find out what does what, so you know how to configure the Mach 3 software. We have Ethernet smooth stepper. We have a USB smooth stepper. This could theoretically plug straight onto here to port 1 or whatever it is, and on this card plug straight in. We have step and direction, and our outputs and input pins follows the same convention of what Mach 3 was designed for. I'm getting to a point, and I'm sorry. UC400, same situation. We have a port 1 and a port 2. We take a cable from port 2, which you can get these ribbon cables that have a DB25, and I could plug it straight onto there and keep going. So here's where the China stuff comes in. So when you're using a motion controller or anything other than a printer port connection from the computer to your electronics, you're using a motion controller, and they have a plugin in the form of a DLL file which goes into the C:\Mach3/plugins folder. That is a piece of software that tells the computer, or tells Mach 3, how to talk to what's ever on the other end. And I've been helping a couple people that have been working with China controllers. Let's see. So here's one. That's a guy that lives right down the road from me. That's what's in his controller. So all of these have some sort of pin and port number assigned to them. And here's another guy that I'm helping. He has that as a breakout board. And all we have is silk screened on here is like XP, XO, YP, YO, ZP, ZO. There's no convention to it. And when I got down to finding some actual documents for it, we can see that none of the conventions, so whereas the standard stuff would be 2, 3 for the step and direction pins, for X is 0 and 6, 17 and 7. These are all on port 1. 0 and 8. And I don't see how you could have the step pin be the same. So they're doing something in their software plugin to be able to have these types of setups, and that's why it's so hard to get support on like these groups, because all of this stuff uses something different, and I can't go through and say, hey, well, this should be this should be that, because the hardware is just not the same. And it's, I'm sorry, but it's garbage, it's cheap, it's junk. Everybody's having issues, especially when they put the VFD in the same controller. And I know somebody's going to come back and say, yeah, well, I've been running mine for 3 or 4 or 5 years and it does everything I want it to do. So great, good for you, you got a good one. But there's so many people out there that's having issues, and I just can't come in and say, well, this should be this and this should be that, because I don't know what any of this should be, because there's so many different manufacturers doing this, and they're using pirated versions of the license file for Mach 3, and we know that causes issues, and they're using not the most stable version of Mach 3. 0.62 is the most stable. 0.66 has got some bugs. But I just can't help without having this type of information. And when I went and downloaded all of these files from the manufacturer's support webpage, when I finally found them, my antivirus popped up and said, hey, there's a virus on this, we can't download this. So I had to grab an old laptop, hook it to the internet with no virus on it, download it, find the crap that was causing the problems, and then keep all the other stuff. And another thing that they're doing is they've got their own scripting and stuff, macros, which a lot of people, they don't understand what any of this stuff is, and it causes issues. So here we have macros for a bunch of different stuff, but we don't have any idea what any of it does. And that's why it's so hard to get support on the machine that you bought, that you were excited about, but now it doesn't work when you get it, because we don't know what any of this stuff does. I'm sorry this is so long. I'm sorry I'm rambling. But keep in mind, I highly, highly recommend ditching the electronics control box that came with the machine and getting something, one, that adheres to the standards of the ports and pins, but two, you know you can get a replacement for it if you get hit by lightning, you get a power surge, or you spill your drink on it, or whatever. I just don't know where to find any of this stuff anymore. Anyway, I'm going to stop rambling. If you watched it this far, thank you, and I'm sorry.